This video is meant for Mrs. Rose's AB Calculus class, and it is our follow-up video on related rates. And the only difference between what we did before and what we're doing now is that we've got a cone shape, which requires a little more finesse. Alright, so in this example, we have a tank in the shape of a circular cone. It is being filled with water, drip, 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 at a rate of 13 cubic feet per minute. It also has a small leak at the bottom. Think like an ice cream cone, just leaks. It is leaking at a rate of 1 cubic foot per minute. The tank has a height of 30 feet and a radius of 15 feet. And we want to know what is the rate of change of the depth of the water in the cone at the instant when the water level is 20 feet high. So when this height here is 20 feet, we want to know what dH/dt is. Let's start with our knowns. We have the tank is being filled and leaking, so our volume is changing with respect to time with positive 13 minus 1, so 12 cubic inches per minute. So that's going to lead us to the volume of a cone formula. So we've got that, and we can't take the derivative. We'll refer back to our earlier derivative. So, because we want dH/dt, so we can take the derivative using the product rule. The problem is we aren't given any information about dr/dt. So when you only want something about dH/dt and you're not given dr/dt, we use a strategy of looking at the ratio of the radius and the height. So the ratio is just going to be 30 over 15 equals h over r. However you want to set the ratio up, that's fine. Just make sure that your height number corresponds to your height variable and your radius number corresponds to your radius variable. And we want to get it so that we can replace r in all of these equations. So we're going to cross multiply and get r equals 1/2 h. So going back up, we're going to go back to our original volume equation and substitute r as 1/2 h. So we've got 1/3 pi r squared times h. So when you square that, we got 1/4 r h squared for a combined 1/4 pi h cubed. Now when we take the derivative, we only have two variables, dv/dt and h, or dH/dt, and we can plug in our dv/dt and the height that we know that h is. And then it's just a simple matter of solving for dH/dt. So we've got 12 divided, or 48, so multiplied by 4, 48 divided by 400 pi equals dH/dt, or if you simplify, divide both the numerator and denominator by 16, we're going to get 3 over 25 pi, which equals 0.0382. Remember, at least 3 decimal places, and then the unit is feet per minute. That's the rate of change of the depth of this cone. For the last example, I'd like you to try it yourself, but the solution that you're looking for is 1 over 9 pi feet per minute. If you need any help, please see me during Kev morning or during class or after school.